Hi students, welcome to the session. I am Dr. K. Varada Rajkumar, Associate Professor, Department of CSE, AIML, MLR Institute of Technology, Hyderabad. In our previous two classes, we discussed about Introduction to Artificial Intelligence and History. In this session, we will learn about Intelligent Systems. So, overview of the session. In this session, we see about Intelligent Systems and categorization of intelligence, and finally we discuss about the components of AI. Outcome of this lecture, at the end of this lecture you all are understand the categorization of intelligent systems and the basic components of AI. Intelligent systems. Intelligent means thinking power. Now if the systems are able to think itself, then we call those systems as a intelligent systems. AI is a combination of computer science, physiology and philosophy. So this computer science deals with algorithms, data structures, and storage. So coming to physiology, it deals with thinking of human brain. So physiology deals with ethics. So now we say that the artificial intelligence is a combination of these three fields. So one is computer science, another one is physiology and philosophy. Now computer science deals with the technology. So for example, we develop these algorithms in Python or C or Java, and so this computer science deals with the data structures and storage. And physiology means it deals with the human brains, how the human brain thinks, so that we call as a physiology. And the philosophy, while developing any AI model, we follow some ethics. So this comes under philosophy. AI is a broad topic, consists of different fields from machine vision to expert systems. So John McCarthy, so he is the father of artificial intelligence, so gave one definition to AI. So that is, he stated that AI is the science and engineering of making intelligent machines, especially intelligent computer programs. Now what is AI? So AI is the science and engineering of making intelligent machines, especially intelligent computer programs. So these are the some of the definitions of AI. First one is, AI is the study of mental faculties through the use computational models. The art of creating machines that performs functions which require intelligence when performed by people. So AI is a field of study that seeks to explain and emulate intelligent behavior in terms of computational processes. AI is the study of how to make computers do things at which at the moment people are better. So AI is a study of computations that make it possible to perceive, reason and act. AI is the branch of computer science that is concerned with the automation of intelligent behavior. So these are the 5 and 6. Okay. So now these are the different definitions given by different computer science scientists. So what is AI means? You understand, we are going to build the intelligent systems that can behave like intelligent humans. Now, so pause the video here. You try to write the definition of AI in your own words. ELIZA is an example for intelligent system. So what is a ELIZA? ELIZA is a chatbot. So ELIZA was program that conversed with user in English. It is basically a chatbot. Now, so this ELIZA program will do some conversation with the user in English. The program was able to converse about any subject because it stored subject information in data banks. So the knowledge already stored in the ELIZA, that we call as a data banks. So another feature of ELIZA was it is ability to pick up speech patterns from user questions and provide responses using those patterns. So based on the user pattern, it will give the response. Okay, so this is the behavior of ELIZA. Here the greater than symbol represent the response of the ELIZA, asterisk represents the response of the user. Now this is the ELIZA response. Hello, I am ELIZA. Now the user gives that, so can you help me? Now based on the pattern of the data, now ELIZA gave the response that, don't you believe that I can help you? Then user respond as a yes. Now ELIZA replies, I see. Now you understand this. Here user gives the input as I feel depressed. Now so based on the pattern, ELIZA gave the response like this. How long have you feeling depressed? This is the response by user since last month. So based on that, again ELIZA gives the response that is quite interesting. Now if you observe here, so this is the depressed. Now so based on the pattern since last month, it gives the reply as a interesting. So what is interesting in this? So have you asked anyone else? No. So are you saying no just to be negative? No, I did not ask anyone. Why no? So if you observe this conversation, so between the ELIZA and the user, you got some doubts regarding the response or response quality. Now these are the characteristics of ELIZA. So one is simulation of intelligent. Second one, quality of response. So third one, coherence. Fourth one, semantics. Simulation of intelligence means how the ELIZA is able to give the response. Is it intelligent or not? We will discuss one by one. Simulation of intelligent. Actually, ELIZA programs are not intelligent at all in real sense. Then how it is able to give the correct response means, so based on the pattern. They don't understand the meaning of the statement. If you observe this, here user enters that I feel depressed. It gives that how long have you been feeling depressed. Actually ELIZA doesn't know meaning of the depressed, but it is able to give the correct response. Why means, so based on the pattern it gives the response. ELIZA don't understand the meaning of statement. Instead these programs simulate intelligent behavior quite effectively by recognizing the keywords and phrases. So based on the keyword, depressed is a keyword and it observes the phrase. So based on these two it gives reply, but it seems to be intelligent, but it is not intelligent actually. So by using a table lookup, one of a few ways of responding questions is chosen. Already all the knowledge is stored in a bank, knowledge bank. Now from this bank it will retrieve the exact answer. It seems to be intelligent, but it is not intelligent system. Second characteristic of ELIZA is quality of response. So quality of response. It is limited by the sophistication of the ways in which they can process the input text at a syntactical level. So now for example, the number of templates available is a serious limitation. So based on the templates, it will give the answer. If your question is not in the template, then it is not able to give the answer. For example, if I ask the question, so what is the capital of India? Now if you reply as a, so New Delhi is the capital of India, then the response is good. If I ask what is the capital of India, then it responds as a, India is beautiful country. Then so these the quality of the response is low. Okay. So however, the success depends on heavily on the fact that the user has a fairly restricted notation of the expected response from the system. Now coherence means logical relation. The earlier version of the system imposed no structure on the conversations. So each statement was based entirely on the current input and no context information was used. So for example, if you give the more complex statements or more complex question, then ELIZA is not able to give the correct answer. So more complex versions of ELIZA can do a little better. Any sense of intelligence depends strongly on the coherence. So coherence means logical connections of the conversation as judged by the user. So for example, so what is the weather in the Hyderabad? If I pose that question, now it says, so Hyderabad is famous for the biryani. Now, so the coherence is very low. It is not logical. So semantics means rules. ELIZA has no semantic representation of the content of either the user's input or the reply. That is why we say that it doesn't have intelligent of understanding of what we are saying. It is not understanding what we are saying. It doesn't know any meaning of the sentence. How it giving the replies means based on the data bank. Already all these sentences are stored in the data bank. From the data bank, it can fetch the data. This data it use as a reply. Okay. So, but it imitates the human conversation style. Because of this, it passed Turing test. In next slides, we discuss about what is Turing test. Now coming to categorization of intelligent systems, we have 4 types of intelligent systems. One is system that thinks like a human, and second one is system that acts like humans. Third one is system that thinks rationally. So fourth one, system that acts rationally. Okay, so let us see one by one. So first one is system that thinks like human. So this requires cognitive modeling approaches. So most of the time it's a black box where we are not clear about our thought process. So for example, if we give the input as a salary and gender and frequency of buying in online. So now if we give these 3 inputs, we are going to predict either he buy or not buy. Okay, so now this is the input we are giving. So based on this input, we are going to predict either buy or not buy. Here we don't understand clearly how we are getting this output, either buy or not buy. Why? It's a you are going to here you are developing a system that thinks like a human, and the thinking level of the human we don't know. Okay, so here the thinking level is black box. That means we don't know the thought process of the human, how they coming to the how they conclude that either they are buying or not buying. So one has to know the functioning of the brain and its mechanism for processing the information. So this methodology we call a system that thinks like human. So focuses on replicating the thought processes of human, such as reasoning, decision making and learning. So coming to example, IBM Watson simulates human cognitive processes to analyze vast amounts of medical data and provide treatment recommendation. Now here, this IBM Watson is an AI system that simulates human cognitive processes to analyze the huge amount of data, and based on that medical data, it provides some suggestions or it gives some treatment recommendations to the user. Second type of model is system that acts like human. So previous one is think like a human. Here it acts like a human. Okay, it doesn't have any intelligent system. It mimics the human. This requires that the overall behavior of the system should be human-like, which could be achieved by observation. It observes the human and then it just mimics the human behavior. So Turing test is an example for this system that acts like a human. So this aims to replicate human behavior rather than internal thought process. So these models will replicate the human behavior. So these systems interact with the world and perform tasks in a human-like way. So for example, take the robot Sophia. So Sophia, the robot can hold conversations, display emotions and mimic human social interaction. But actually it doesn't have any internal thought process. Just it try to mimic the human behavior. So now we see the Turing test. Okay, what we discussed in our previous slide. So Turing test means that system acts like a human. So consider here there is a interrogator in room C. Now, so this is the room A and room B. In room A, there is a human. In room B, there is a AI system. Now, if this AI system acts like a human, then we say that this system, AI system, is passed Turing test. Okay, so what is the Turing test? So Turing test was introduced by Alan Turing in 1950. A Turing test is a method of inquiring in artificial intelligence for determining whether or not a computer is capable of thinking like a human. Okay, if this human interrogator not able to understand the AI system as a AI system and he identifies as a AI system as a human, then we say that this AI system passed in Turing test. So what is a Turing test? It is a method of inquiry in artificial intelligence for determining whether or not a computer is capable of thinking like a human. So here, so Turing proposed that the human interrogator in room C is not able to identify who is in room A and who is in room B, then the machine possesses intelligence. So for example, here consider I giving the input as a 2 plus 3. Interrogator gives a problem that so 2 plus 3. Now human will give the input 5 and similarly AI system is also gives the input as a 5. Now, so this interrogator will not identify who is in room A and who is in room B. So if the answer is like this, for example 4, 5, 6, 7. So this is the problem posted by the human interrogator. Now, so human will take some time to post the answer. But coming to AI system will give the response very quickly. But AI system is also thinks like a human and it is also giving the reply as like human. It takes some time to give the reply. Then this interrogator doesn't identify this AI system as a AI program. So this AI system passed Turing test. So Turing considered this is a sufficient test for attributing so thinking capacity to a machine. In this example, this AI system tries to mimic the human behavior. As of today, so Turing test is the ultimate test a machine must pass in order to call a intelligent test. Okay, so this is about Turing test. So third type of intelligent system is system that thinks rationally. That means here we follow the logics, this relation logic rather than human to measure correctness. Uses logic based approaches to mimic rational thoughts, ensuring the decisions and actions are logically correct and consistent. So for example, John is a human and all humans are mortal. Now based on these two statements, logically it says that John is mortal. Okay, so these type of systems we call as systems that think rationally. Fourth type of intelligent system is system that acts rationally. So this is the final category of intelligent systems whereby rational behavior mean doing the right thing even if the model is illogical. That observed behavior must be rational. So this focuses on taking actions that achieve the best outcome. So even if the underlying process is not similar to human thought or logic. Even if the underlying process is not similar to human thought or logic, but it is able to generate the best outcome. So this type of category we call as a system that acts rationally. So focuses on taking actions that achieve the best outcome. So that we call as a rational behavior. Why? Even if the underlying process is not similar to human thought or logic, but it is generating the best outcome. Okay, coming to example, so autonomous vehicles. If you consider autonomous vehicle means vehicle without driver. So this self-driving cars acts rationally by analyzing their environment and making decisions, so based on the stopping at red light or avoiding an obstacle to ensure safety and efficiency. So based on the self-learning also, it able to complete its task. Okay, so this model autonomous vehicles we consider as a systems that acts rationally, so they will give the best outcome. Okay, so coming to components of AI, three components we have. So one is knowledge base, second one is control strategy, so third one is inference mechanism. So coming to knowledge base, so knowledge base means AI programs should be learning in nature and updates its knowledge accordingly. So knowledge base generally consists of facts and rules and has the following characteristics. One is it is voluminous in nature. Voluminous means a huge amount of data and requires proper structuring. It may be incomplete and imprecise. It may be dynamic and keep on changing. Now, so it may be incomplete or imprecise. So incomplete means sometimes the data we are giving without filling a particular field, and some data will be changed dynamically. For example, if you develop any autonomous vehicle, so that follow some rules, maybe the rules may be changed. Okay, so it may be dynamic and keep on changing. And second component is control strategy. What is the first one? Knowledge base. So knowledge base means facts and rules. Now control strategy means determines which rule to be applied. So knowledge base, we stored all the facts and rules. Now we apply. Now control strategy means what rule you apply to solve a problem. To know this rule, some heuristics or thumb rules based on problem domain may be used. Based on the problem, we are going to select a heuristic function to find which rule you are going to apply. So this we call as a control strategy. Inference mechanism. It requires search through knowledge base and derives new knowledge using the existing knowledge with the help of inference rules. So now, so x belongs to y, so y belongs to z. Now if these two are the rules, then we say that x belongs to z. So this is the x belongs to z we got with the help of inference mechanism. Okay, what do you understand from components of AI? We have three components of AI. One is knowledge base, second one is control strategy, so third one is inference mechanism. So knowledge base means so facts and rules. Control strategy means which rule you are going to apply. So this is based on some heuristic or some rules. Based on some rules you are going to find, so which rule you are going to apply to solve a problem. Now inference mechanism. So inference mechanism means you are going to derive the new knowledge from the existing knowledge. So that we call as a inference mechanism. I hope you all are understand the intelligent systems and components of AI. If you have any doubts, place your doubts in the comment section. I will answer all your doubts. Thank you.